An operating system for the shop floor, if you think about this metaphor, right? Basically, operating system have three parts, right? It has the interfaces through which people interact with the system. In our case, they could be, tablets or smartphones. They can even be like small buttons or machines that we hook up to the system. It has a driver layer that allows you to connect things to the system. And it has a central processing, or a brain, if you like. And that's obviously the cloud in Tulip's world, right? So the second layer, the driver layer, is, people use different names for that. We use IoT, or industrial IoT. That's the realm this stuff falls into, which is essentially very small, inexpensive computers that you can deploy nodes to the floor, and they provide connectivity to machines or sensors, and that's sort of like a typical sort of IoT statement that I just made. The thing that we do very differently, enable this operating system, is that we want people to just plug and play sensors, whether it's a barcode scanner or an RFID, or just a simple proximity sensor, or it could be a full machine doing surface mount technology type operation, and you just want to communicate with that machine. Those things in our heads are building blocks, and they need to have drivers. What the cloud does essentially is two things. First, it's an authoring environment that allows you to create those shop floor apps, because an operating system has applications. When you think about an app today, even just the app on your phone, you don't really think about it, but it has some flow, it has some data that it's collecting or you're consuming, and it allows you to do things. For example, talk to your bank, right? So typically, developers write those apps, and we call them information technology apps or something like that. What is that for manufacturing? Like, we don't, there's no tens of thousands of developers that live in that manufacturing space that can sit down and write those apps, because there's no real market for that. So what our cloud authoring environment does is allows you to just drag and drop and very quickly in a PowerPoint style kind of create those apps. Connect all the different data faucets and links, and basically create a pretty sophisticated app in minutes and deploy it to the floor. And that app could guide an operator or facilitate a quality assurance process, or can train an individual how to do something, or it can monitor a machine process, and nobody wrote code. And then, because those apps are live and active, you can just hop on the back end and start querying our analytics system. And this is real-time analytics, so anything that happens on the floor that a person or a machine or a sensor did, you can basically introspect and crisscross it with a bunch of tools that we've created. And that's pretty powerful, that combination of those apps, the data they collect, the sensors and machines they talk to, and I think that's the core of this idea of an operating system, that eventually what will happen to this platform, and the way we're designing it, is that it will be extensible. So we're not doing this right now, but the idea is that the device manufacturers could create their own drivers and certify them for the platform, and because manufacturing is as big as what humanity does, right? That's like what we do. We're a technological species making things. So you can't imagine that one company will be able to know all the things about biopharma and automotive and electronics. So what will happen is, like, various templates for those apps would emerge. So people could very simply say, well, I'm a automotive supply chain manufacturer, and I build this type of widget, and this is like the best practices to build this type of widget, as opposed to someone using the system to create a process to support drug development in a biopharma, for example. The connecting thread here between those very different industries in this example I just gave you is the fact that in manufacturing, despite what popular tech press might say, people will remain a dominant factor, because people is the most expensive and intelligent computer you would have on your line. It's people who would have the spark to figure out how to make the process better, and it's manufacture something 2x cheaper. And it's people who would train the next batch of people, and it's people when they're tired and had a bad day that would make the terrible mistake and reduce your quality. So you have to create, I think we can agree by now that there's certain things computers and machines do very well, and there's certain things people do very well. And I think to have manufacturing that is set for this decade, era, whatever, you kind of have to build interfaces for those people in the environments which they do work. And that, that's where we see, that's why, at Tulip, one of the things we're saying is that, behind every product there are people. We don't see that changing, no matter what is being made.